This is Mario once again with MIA Microflight, and in this video I'm going to be talking about the MIA uh, bow tie connector end. Basically, that has to do with the pressing of the EMT tubing. This is 3/4 inch EMT tubing. It's not exactly 3/4 inch because if you measure it, I think it's somewhere around 0.94765, something like that, is the actual diameter, but they call it 3/4 inch EMT tubing. I've been doing this since I started buying maker pipe connectors, and it's been a while, since I've been doing this. So I developed a die, 3D printed die, to do this type of dents here on the ends of these maker pipe connectors, and I did this so that this would grab onto the maker pipe connector, which has a 1/4 inch bolt right through it and a nut, retaining a nut. So I did this so it'll retain itself much better than having to just clamp it and just rely on just the force of the clamp itself, or having to drill the maker pipe connector with a hole and through this pipe also with a hole, to retain the pipe more permanently. So I did this, which is a lot better. It did require a lot of experimentation, to get this what I call the MIA bow tie pressing, to the point that you see it here on this sample piece of EMT tubing. And so that's the reason for this. And what I'm doing in this particular video is I wanted to explain a little bit about that, but the reason I'm doing this, because this is my front end. It is one of the tubes is about 24 inch in distance, and I'm drilling these at the end. So I created these additional jigs here so that I can put the tube, have the tube parallel throughout the drilling here. So I have a hole that I'm drilling at the end, and that hole is going to be enlarged to a 1/4 inch. Right now this is just a 1/8 inch drill bit, so that it fits on my tooling, on my 3D printed die, in the way that I'm going to show you in a little while here. So I'm doing this, but I needed these blocks here so I can retain this tube with a little more precision, and I can drill these ends at the same line that you see there, all the way across the other end. That one's already drilled, and so that it comes out nice and parallel and true, nice and vertical. And so I did these little blocks here, these 3D printed blocks last night, and I just finished drilling 2 of these tubes that form the front end of my racing go-kart, which I've modified to this setup here. In instead of the original one that I had, I only had a single bar, in the original one, and that was it was flexing, I think, a little bit on the connector that I had. So this time I went with 2 of these tubes, and that kind of resolved that problem. And now I have a nice solid front end here. These are the tubes that hold in sort of a C bracket the spindle here, and the spindles also I'm redoing them. I'm actually welding. I actually welded from angle iron. I made a kind of a C type spindle, C bracket spindle that fits inside, that fits between these two bars right here at the front. These 2 bars create the bracket, the C bracket, the upper and lower retention bars or brackets that hold the spindle, the one that holds the wheel, the front end. And so I'll be showing that in a future video as I'm working on this, because once I get done with this, then the maker pipe connector will clamp a lot better here. We're talking about just a straight connector that has the a vertical slot, and that's where the bolt goes right through to hold the C bracket, for the spindle on the wheel. You'll see that in the future video, but in this video I just wanted to showcase this MIA bow tie geometry here, using the 3D printed dies that I created. In order to do the pressing of this end right here, I need to come and cut these slots here. These slots are cut at 25% of the height of the tube, or the diameter. And that leaves about 50% of material here when this is pressed, as you can see here. 25% from the top is the slot or the slit, 25% at the bottom. And when I press this, that comes out nice and symmetrical, or as symmetrical as possible. Um, so I use this tool right here. It's just a tool that I've had for also many years. That I cut different types of tubing here, lengths, mainly metal tubing, and I have this. This is just a cut off tool here, and this is I believe these are 3-inch blades, and so I put that there, and then I come back, or I just do it manually, kind of eyesight the kind of eyeball the markings here, you know, so that I can create those slits. Once those slits are done, I put them on this 3D printed die, and I did this die just from PLA, and it works just fine. PLA. This is these pieces are the ones that press. These blocks, these are the ones that actually do the pressing, because these are just guides. These are outer blocks. This is done at 100% infill, so it's a solid piece, and you want that at 100% infill because you don't want that to collapse. I believe I did these other ones also at 100% infill. Yeah, because they are heavy. So everything's pretty solid here. 3D printed. It took a little while to print these, but once I had these, they worked fairly well. You can see that I've used these quite a bit here because they're getting worn out here. The shape is beginning to lose. It's a bow shape or bow tie shape, but this is one of the better pieces that I did using this die here. And so with that hole created, it allows the pipe to go inside this pin right here, and this pin is attached to one of these blocks, and that's just for retention of the tube. And then I lock this at the top right here via these 4 bolts right here. Once this is clamped there with the 4 bolts, I put this on my I believe this is a 1-ton press. I put them there, and then I start compressing the tubing here. And when I'm done, it creates this bow tie geometry here that allows me to insert this into the maker pipe connector and reuse the same bolt, the hardware that comes with the maker pipe connector, the nut and retaining nut, the bolt and retaining nut rather, and more securely, more permanent, without having to drill another hole through the maker pipe connector and through the EMT tubing. So this is a much better proposition. I started doing this when I started building my racing go-kart, because I wanted, when you're building a racing go-kart that's not going to be welded, you want some secure way of attaching these things. Now, there's another gentleman that I think is also using or was also using maker pipe connectors, but I noticed that he was drilling through the maker pipe connector and the tubing. He doesn't have this setup here. I created this setup because I didn't want to drill right through the tubing or ruin the maker pipe connector with another hole. So that's the purpose of this particular die that I did on the just on the basis of the need to have something more permanent. They say that necessity is the mother of invention, and so that's how this came about here. This die, for manufacturing something like this could be done in steel, but that would incur a much higher cost than what you spend just on PLA. So for hobby purposes, PLA is working just fine to do this type of indentation here. And so this is my die, this is my setup, and this is how I approach these things right here. Once I'm done with those bars, I need to slit them at the ends. Those bars will become the front end, like I said, more permanent with the maker pipe connectors, and I'll show you that in my next video with regards to the mods that I've been making to my racing go-kart, just making a lot better, for steering, for drive. My drive system is my drive system on my racing go-kart. I changed that. I went from the complexity of using the chain drives with the sprockets. I had 2 of them, each motor driving, and it's via chain drive 1-to-1 ratio to a sprocket that was part of a bicycle hub that I adapted to fit the shaft. It was just too complex, and it bothered me. When I did that setup, it worked to some degree, but uh, there's nothing more clean and nothing more elegant and more efficient than going with the direct drive with the hub motors. So I don't want to I removed all that complexity. I took the hub motors and I modified some PU wheels and I fit that. I have another video that explains that. Go check out that video if you're interested in finding out how I did that, and I resolved that issue with the complexity that I had before. Much lighter setup, much more efficient. My go-kart is able to handle a lot better. And I also did the front end. I improved on the front end, some of the angles. I removed some of the. I had a caster. I still have caster, but I also had camber there and kingpin inclination the way that I did originally. And so I removed the kingpin inclination, just went with straight, because my other go kart that I did with 1.5 inch square steel tubing, that one does not have camber, and that's working beautifully. So I decided, I'm not going to be racing these things. I'm not, this is just for fun. Simplify it and just keep it nice and sweet. So check out those other videos. I try to make all these videos more of more as a diary than to get a lot of views. I don't get many views, and for some reason the algorithms just don't promote me as I used to. I used to get 100,000 views, on some of the videos that I used to do many years, and it's kind of pathetic that I only get like 35 or not even 100, sometimes. So it's I don't know what's happening there, but I had my suspicions. So I'm not going to go too much into depth about that, but those those algorithms are interesting. The way they promote some and the way they promote some other ones that are really crappy videos. I've seen a lot of videos. When I get into projects like this, I see who else is doing something similar, and I rarely find people that are doing similar things. A lot of stuff, like I said, is by necessity. This came out by necessity. I needed to do this. I went online, said, nobody's done this before. Nobody had any tools. The hell with it. I'll create my own tool. Will it work with PLA? Just do it. Do it and see what happens. I did it and it worked. So that's how these things come about. But as far as the views, I don't get many views. I would like to get at least 100 views on some of these videos. But I'm doing this more for the sake of recording, in case my kids or my grandkids ever stumble on these things, or other people stumble on these things in the future, and it may serve them as a point of reference. This is Mario once again with MI Microflight. Stay tuned for the continuation of this project, which is part of my modifications that I'm doing to my electric powered hoverboard motor, repurposed go-kart done with EMT tubing, and of course maker pipe connectors, some of my better and favorite connectors of all time. Stay tuned for more.